The topic of this presentation is need of geographic information system in construction. This entire presentation has been divided into three parts. First, we will start with need of surroundings. After that, we will discuss what the surrounding is. Then after this, we'll discuss how GIS or geographic information systems are helpful in modeling of surroundings. So let us start with the first part, that is need of surroundings. Whenever there is a construction, generally we communicate what is to be constructed with the help of 2D drawings. To avoid the problem of visualization of 2D drawing into 3D, we use 3D models. 3D model externally as well as to model building internally. But what happens if construction is to be carried out always on a particular location or on ground? It can never exist in isolation. Its surrounding play a major role in its construction planning, in its execution, or during its life cycle. Therefore, instead of looking this construction in isolation, we need to have the knowledge of surrounding, or we need to plan it with respect to surrounding. Or in other words, just like we model 3D model of a building, just to model interaction of a building, construction or facility with its surrounding, its modeling of its surrounding is also necessary. Generally, what is done, we model a building or facility in isolation, or we develop 2D drawings or 3D models. Then we mentally think that that building or structure is to be constructed at a particular location, and we try to visualize execution sequence, construction, or its life cycle manually. Then what happens that visualization of execution sequence, its construction or life cycle, that vary from experience, knowledge, or individual perspective of a planner, how he or she understands surrounding, or how a planner interpret interaction of that particular construction or facility with its surroundings. A building or structure, either it is small or big, become an important component in a particular society, in a particular location. Even its existence either affects surrounding, or it itself get affected by surroundings. So we cannot neglect surroundings. Or in other words, we say that a building cannot remain in isolation, but it is closely related to its surrounding, whether it during its construction, even after construction, or there are so many planning which we do before its construction. So we need to have the knowledge of surrounding of a particular facility or building. Other thing that come into picture, that is site feasibility. Whatever we plan, that plan must be in line with its surrounding. Whatever construction or execution plan we finalize, we must keep in mind that what are the site constraints, how that construction going to affect surrounding, or how that construction is going to affect surrounding, or relationship among existing and the proposed construction. Therefore, sites need to have the knowledge of surroundings along with the construction which is to be carried out. So site feasibility of a construction or its plan is considered to be significant factors. Another thing that is being given much significance nowadays, that is sustainable construction. We cannot think about sustainability without considering surrounding. Therefore, to consider or to make construction sustainable, to make its life cycle sustainable, we need to model surrounding. We need to understand the interaction of that particular building or construction with the natural ecosystem. How that construction or building going to affect its environment or ecosystem, or how it is getting affected by the environment or ecosystem in that particular building is to be or facility is to be situated. So if in general I say every structure in architecture, engineering or construction we locate, it always lies on ground or in a particular locality or in surrounding. Its existence affect its surrounding or ecosystem, or other way also, its surrounding affects its life cycle. Therefore, we need to consider surrounding or interaction of that particular facility or construction with its surrounding. So in the second part, we will just discuss that what surrounding actually is. So first thing, whenever we talk about surrounding, that is location, where that particular site is located. So entire construction plan, its sustainability, its life cycle, or during construction planning, everything changes if a particular location change. If let's say building is to be constructed in a plain area, then plan will be different. If it is to be constructed highly congested area, will be even we don't find space to store material, then everything plans life cycle is different. If let's say same building is to be located on a hill where topography play a major role, then also planning is different. If sometime in some critical weather the construction is to be carried out, or if its life cycle is to be understand, then also we need to have the knowledge of surrounding. So first thing when we talk about surrounding, that is the consideration of location of a particular facility or building in which it is to be located. Second thing, topography. Topography play a major role. If it is a tough topography, then plan and execution is different. If it is a gentle or a medium topography, then also its plan and execution changes. Or in other words, if I say a construction or facility cannot remain in isolation, but it is closely related to its topography. The third factor, that is what are the existing facilities or utilities in that particular area or at that particular location where construction is to be carried out. Those facilities or utilities include approaching road to that particular site, or we need to construct road, existing pipeline network, drains, electrical lines. There are so depending upon site or project. So this existing facility or utilities at that particular site play a major role. The fourth thing, every site offers some constraints. Just like there are the building bylaws which changes from one location to other, which need to be considered. Distance from nearby building or nearby facilities, distance from local market, or location or layout of existing water supply or sewage lines, availability of local raw material or labor. These are all site constraints which vary from one place to other place. So just to keep these constraints in mind, we need to have the knowledge of surroundings. Then we need to extend some services or some minimum required services to that particular construction site, which include approaching road, where topography play a major role. If let's say the site is hilly, then we how to construct that approaching road, how to connect the site under consideration with the existing roads. We need to look where water supply connection is available and how to bring that supply to that particular site or sewage network, so that how to connect the location or construction site with these services or facility, that also play a major role. So whenever the construction is to be carried out, surroundings play a major role, and we cannot neglect surrounding. Execution of a particular construction or planning for execution or its life cycle entirely depend upon surrounding. And surrounding is in general considered manually. Therefore, we need to model surroundings also to have sustainable or unique solution the way we model the way we model a particular building. The geographic information system is a technology which is widely used to model surroundings. If we model surroundings, then we have same model of surrounding just like the model of building. So now we'll go that how to use the GIS to consider the modeling of surroundings. First, if let's say we are modeling a particular construction or execution sequence in isolation, that means without considering surrounding, that is one thing. If we are planning a particular construction or its execution along with its surrounding, then it is different thing. So it will lead to a coordinated or integrated solution or executable construction plan. So in general, nowadays what we are doing, we are modeling facility which is to be constructed in isolation without giving due consideration to surroundings. If consideration to surrounding is given, that is in general given manually. If let's take now how to model surrounding, the first step in modeling of surrounding will be the modeling of topography. So this slide shows how this topography has been modeled. Now here if we see the existing buildings have been placed on the respective locations to give this 3D view. So we have topography and we have the facilities which are lying on their respective places. Now here the services, which may be the overhead electrical lines or water supply lines or sewage lines. So now this is actually the simple model of the surroundings, which include topography, which include existing facilities and utilities. Another view now how that supply is to be given from water tank, which is located on the top of hill, to the different houses or different plots. So layout of this pipeline from origin to destination has been given. Another, this the modeling of this railway line. So along with this, where we have the layout of public utility services, like electrical lines, gas supply lines, water distribution system, and sewerage network, or other land use which are already there in GIS. So if we consider GIS to model surrounding, so all these things which play a major role in construction planning or during execution, these are already available in GIS. So these things will facilitate, or these things will make our plan executable or facilitate during execution also. So these things are already available in GIS. So this makes GIS a better solution for modeling of surroundings. Other thing which we require, that is the geospatial analysis or geospatial modeling. Let's say construction is to be carried out on a particular hill. So that those things cannot be modeled without geospatial modeling, which are available in GIS. So that also strengthen the need of GIS in modeling of surrounding. So any construction which is small or weak, because that due consideration is to be given its surrounding, and that surrounding can be modeled in GIS. Now I will just differentiate this GIS from the CAD world. Whenever there's a particular construction, whether it is in architecture, civil, or AE industry, which we call architecture, engineering, and construction, we have some text information, and we all know that for a particular construction, along with that information, we have the graphics also. So if we see this is the CAD world side. So we have developed very good tools or software tool to deal with this text information and the drawing information. The people who were working in text information, they have developed this Microsoft Word or other DBMS tools. Same way we have developed very good this modeling tools or graphics tools, just like AutoCAD. But what happens to people who are working in this database management side, they have developed very good facility in that the people who are working in this drafting side, they have developed very good drafting capability. But later they realize that they need both on a common platform, because both belong to a particular facility or a particular building or a particular structure. So why two different things? Along with that, just like there's a particular building, for estimation we use one tool, for planning we use one tool, for drafting we use one tool, that lead or that develop different formats. So why not everything on a common platform to remove this interoperability problem? So these then the people thought that let us bring everything on a common platform, that lead to the development of building information modeling. So now we try to do maximum things together on a common platform, which is called building information modeling. Rebit and Graphisoft are the widely used tool in this building information modeling. If we go the other side, same way the research here also, they have developed very good text tool to deal with the text information. They have developed very good tool for map making, but they realize later on they need both things, because map has information, that information may be in text, that information may be in numbers, and that cannot be put always on hard copy map. So that if the map belong to a particular area, so why two different tools to deal with the information and the graphics? So same way they felt the need of a common platform here. So here the graphical information is called spatial, because here everything that is related to the location, which has reference to a particular on the surface of Earth. So here graphical information is called spatial information, and non-graphical information is called non-spatial information. So here they also felt the need of a common platform, which lead to the development of geographic information system. Then here people who are working in this architecture, engineering, and construction industry, they felt that everything lies on ground and they cannot neglect ground. Then the people of A industry felt the need of geographic information system. And mainly there are so many analyses which can be carried out, mainly to understand that how building how to develop executable plan, how to make construction sustainable, or how to develop that life cycle of that particular building sustainable. Now, if we see here that this is the a particular building which has been circled, and that building has been developed in the building info, some building information modeling software, and that has to be placed in its surrounding, and that surrounding has been modeled using geographic information system. So we need 3D modeling of surrounding using GIS along with this facility which is to be developed. So now here we can understand its construction planning, its under execution, and its life cycle or its interaction with its surrounding. Another building which has been circled, that has been modeled in BIM and has been placed in its surrounding. That surrounding has been modeled in GIS. So this way help in understanding or developing executable plan, or to develop a sustainable life cycle. So if I conclude this first part, consideration of surrounding in construction planning, execution, or life cycle is like judgment in monodisciplinary to multidisciplinary perspective. The use of GIS provides a multidisciplinary approach for sustainable construction planning. The more detail, if anyone is interested, so this is the manuscript that has been published in a journal. So you can go through this. So thanks a lot for being with me. Thank you very much.